Hello, my name is Courtney Osborne, and today we're going to be doing a advanced mushroom cultivation course here through my business known as Myco-Op. So a little bit about Myco-Op. Have about 10 years of mushroom growing experience. I've grown, quite a large amount of mushrooms, a little over about 2 million pounds or so. Kind of lost count over the years. But I do a lot of scaling solutions, teaching, helping with research and grant projects. I have about 100 plus genetics in my culture bank. And yeah, here's a little bit about some of the places I've worked over the years. We used to use this big retort in the middle there. It's a big pressure cooker that sanitizes your substrate, your wood material, or whatever else you're growing on. If you look to the far left, you'll see about 10,000 pounds of substrate loaded up, ready to go into this 36-foot retort. And then there you see some lion's mane growing on the second to left side there. And we were producing quite a bit of mushrooms when I was in my prime. I am now mostly focused on doing consultations and research and development. Um, and then here on the right side, I actually have a photo of me presenting at a, what's it was the Bell Museum. If you're familiar with Minnesota, we have a museum that's related to our university, and I was presenting a little bit about my current research projects that I was working on at the time. This was a year or two ago. Here's another photo of some of the things I've been doing. I do a lot of teaching around the cities here, cultivation courses, just to get more accessibility to the local community and teach people the basics on what you need to get started, and just to get people a little more familiar with the environment around them and what they could cultivate in their environment. And here on the left side, you see a photo of me presenting what's known as the wrinkled peach mushroom. It's Rhodotus palmatus. And on the left side, you can see a cultivated version that I produced that is lacking pigment and is a little bit larger than the wild version that's on the right side there. And you'll see the darker pigmentation on the cultivated side. You can't see it from the photo that I have here listed, but you'd also see quite a bit different in the amount of fresh air that is causing the wrinkled cap on the peach here. So if you were to flip these two mushrooms over, you would see a little bit more about uh, what the environmental parameters do to encourage the different phenotypical expressions that these mushrooms all have. In the middle here, you see a little bit about me producing and showcasing, some different cultivation methods that are really easy for people who are just trying to learn at home using pressure cookers and a still air box, that sort of thing. And then on the right, this is a professor that I work with. His name is Bob Blanchette, and he is a plant pathologist professor at the University of Minnesota. And he helps me with a lot of the DNA sequencing that I do to verify some of the genetics that I work with for my local environment. So here are some of Myco-Op's goals. A little bit more about me. My name is Courtney Osborne, if you didn't catch that at the beginning. I'm the founder of Myco-Op, which is a fungal research and development laboratory, which I mentioned, and we're located in Minneapolis, Minnesota. Um, yeah, and I think I mentioned a little bit about me cultivating for a little over a decade, and I usually am focused on bringing a lot of these newer species or uncommonly cultivated species to larger scale production. And my work also focuses primarily in the private sector, helping businesses nowadays, and collaborating with research projects and grant funded projects, that sort of thing. Over the course of my career, I've grown, a lot of mushrooms, and I've seen a lot, over the years, and what can be possible, and what you know the future might look like in mushroom cultivation. So I've been leaning heavily into some of the native exploring the native species that Minnesota has to offer and the Midwest has to offer. You can see some of these photos on the right here. You'll see the far right on the top, you see a mushroom known as beefsteak fungus or Fistulina hepatica. This one I am really interested in because not only can you eat it raw, but it just has a really, really unique flavor. It's almost like a lemony tartness to it, and it's really interesting, I find. And then below that, you'll see a mushroom known as Hericium coralloides. That is a species that's related to the lion's mane mushroom, if you're familiar with lion's mane, which is just our local variety. I don't find too much of the Erinaceus where I'm from in Minnesota, but it definitely grows. That species grows across the U.S. as well. Um, and then on the top left here, you'll see a mushroom known as Lentinus laevis, or it used to be in Pleurotus, but now is in Lentinus. And this mushroom is pretty resilient. I'd say it's one of the most aggressive fruiting mushrooms that I've ever seen or used. It will start fruiting on anything from a petri plate, even in liquid culture. And it produces quite vigorously. I would compare it to something like the invasive species of golden oyster. So a lot of what my focus is trying to get people to stop cultivating invasive species and start focusing a little bit more on what their local environment has to offer. And then down below here, that Lentinus species, which kind of resembles an oyster. But below that here is what's known as Flammulina volutipes, also known as the golden enoki. There's also a white version of this, which is Flammulina filiformis. But the volutipes is the one that actually grows locally near me. So I focus a lot of my time, like I said, cultivating native species and trying to find new things or hard to grow species. So one of my actual recent projects as well was, or my recent contributions was isolating a fungus that was in the Metarhizium genus, which is an entomopathogen fungi, which mainly focuses on targeting bugs and insects. But the University of Minnesota and the plant pathology department that I was mentioning earlier is working on researching this Metarhizium species for biocontrol for the emerald ash borer. And if you're not familiar with the emerald ash borer, this is just a pest that likes to target the ash trees. And today, my work at Myco-Op focuses primarily on liquid culture fermentation utilizing bioreactors. Um, that's a huge part of me trying to teach people on how to not only minimize labor-intensive practices, but to keep things efficient and consistent as you scale a business from a small-scale business to a larger-scale business. It is also very cost-effective. I also focus my time, like I said, researching a majority of it, developing these hard to grow saprophytes, some mycorrhizal species, but I'm highlighting a majority of it on the native fungi. So I'm going to go a little bit into the cultivation cycle of how all mushroom cultivation starts and ends. And once you go through the cycle, you kind of flip back and start at the beginning again. But this means either you are starting with a mushroom spore or a piece of mushroom tissue. So say if I went out into the woods and I collected a fresh mushroom, I could take it back into my lab. I could take a piece of that tissue, put it onto a petri plate, and then that mycelium from the tissue would in turn grow on the petri plate, or spores would germinate on this petri plate. And then once that grows out, you would take a piece of that tissue or that mycelium that is growing and sector it away, which sectoring just means to, in a sense, take a piece of the clean mycelium and transfer it to a new plate. And you may have to do this a few times, depending on how dirty the sample is you're working with. But once you have a clean, isolated mycelium that is growing on the petri plate, you can then go ahead and either make a liquid culture or use that Petri plate to inoculate some sort of spawn. And a liquid culture I find to be really helpful because you can expand this liquid quite significantly, which is a bit about what my talk today will be about, utilizing bioreactors and why there's such a benefit to utilizing these in large scale applications, even small scale applications. But let's say you have a successful, myceliated plate, and then it's clean. You're going to transfer it and make a liquid culture. You could use that liquid culture and then make what's either known as grain spawn. You could make a sawdust spawn, or you could skip the liquid culture step and go straight from the Petri plate right into making a spawn as well. But I find that to be quite a bit slower, and as you scale, it just becomes a lot more clumsy, and you're going to be making a million plates as you become a larger farm, and it just becomes really tedious work. You don't want to be transferring and wrapping a million plates all day long. You could just have a liquid culture, and that one liquid culture bottle could equal up to 50 Petri plates. A Petri plate is very 2D, whereas a liquid culture is 3D. So once you make a spawn, I think a lot of people are pretty familiar with a spawn or what that is exactly. And like I said, it could either be a grain spawn or that could be a sawdust spawn. It could really be any medium, but ideally the spawn is just a medium that you're using to inoculate your final substrate, which you'll be fruiting on. So once you have that spawn, you're going to introduce it to whether you're growing on wood, a supplemented wood. A lot of people supplement with either soy hulls, wheat bran, a lot of different applications you can use. The more things that you can get from your local community for free, the better and easier it makes this whole process. You usually want to start with dry ingredients so you can hit a specific moisture content, because mushrooms are very sensitive to this sort of thing and they require a pretty consistent moisture content throughout their life cycle. But once you have a spawn that goes into your substrate, usually when you make the spawn at first, that takes about anywhere from a week to 2 weeks, sometimes longer depending on the species. But then you would add that to your substrate. Once that's in the substrate, then you would have another 1 week to 2 weeks depending on the mushroom species. Again, it can go all the way. Colonization phase can take all the way up to 2 months with some of the more difficult species to grow. But let's say you were successful all the way up to this point, and then you were ready to fruit your mushrooms. So then you take that substrate or that mushroom block, and then you would put it in a grow room. Um, and that grow room, you'll just, grow your mushrooms out. And then if you want to start this whole cycle over again, you would either collect tissue from your mushrooms that you grew or collect spores and then start all the way back over at the beginning of the cycle again. A lot of people who work with commercial genetics will have pre-stored myceliated plates or Petri plates that are, kind of at the earliest cell divisions that they can then in turn just keep making liquid culture or making spawn from, and then continue the cycle from 2 to 6 instead of going all the way back to 1. But let's say your genetics are getting really weakened over time. I would say then you really probably want to focus on going back to a spore to really get the vigor back into your genetics that you're working with. So let's talk a little bit more about what a liquid culture is. I'm not going to get too in depth with all the different types of things, but just understanding what these are can help significantly in the end goal that you might have. So let's start with sugar. A lot of this is mainly based, your backbone of everything is just a sugar source, a sugar water. You could use simple sugars or complex sugars, and depending on whether you're utilizing your liquid culture quickly or plan to store it for a long time, you might want to have a different ratio of a simple sugar versus a complex sugar. And in my opinion, I do a little bit of both to find a happy medium between the two, just because you never know if you're going to get to your liquid fast or slow. Just depends on what scale you're at and your end goal. After that, you have a few different things like your organic nitrogen or your inorganic nitrogen. I tend to lean towards organic nitrogens, such as peptone or yeast extract, but you can use quite a few other different medias. Some people will use inorganic nitrogen, but I tend to stray away from those. But then after that, you got your water. And usually I suggest everyone to start with distilled water, which is always going to be pH neutral. So you're not going to have any sorts of imbalances or inconsistencies in how and where you are in the world doing this same process. It also is always contaminant free and very mineral deficient. That's why it's very consistent. And then we'll talk about some stabilizers here. You got potassium phosphate, calcium carbonate, uh, and then a few of these other ones. But mainly they're just there to keep the pH in check as the mycelium digests the media, whether that be your petri plate or a liquid culture. But mainly as mushrooms break down and degrade their environment, they're creating a more acidic environment in that process. And next, you'll have your supplementary minerals like calcium sulfate, magnesium sulfate, and B vitamins or trace minerals and elements. These are kind of a hit or miss. You don't necessarily need to use these as you scale up and really start producing a lot. Adding things like this, it just depends on what you're doing. If you're trying to produce certain metabolites and enzyme production, which also kind of goes hand in hand with these amino acids, you might want to really start focusing on utilizing that or producing mycelium for functional mushroom extract or something like that. But you would also, in that turn, also want to be adding certain amino acids to make sure that some of these metabolites and enzymes are actually being produced. Things like L-tryptophan, L-methionine, or phenylalanine. That's a tricky one. But yeah, some of these things are all different for each mushroom and each compound that you're trying to produce in a liquid. So now I'm going to talk a little bit about the bioreactor aspect and what a bioreactor really is. So a bioreactor is just a specialized fermentation vessel, and this will provide a controlled environment for growing fungus at an optimal temperature, pH, oxygen level, and nutrient supply. And ideally, you would mix and aerate inside this reactor, which you'll see these pearls forming on the side here. That's because I'm using air inside, which I'll get into a little bit later. But you'll either use a little magnetic stir bar on a stir plate, or that in combination with air to really increase the dissolved oxygen. But either way, if you use both, you're really going to get the best dissolved oxygen possible, which is kind of the end goal. Everything really revolves around how much oxygen they have available, and obviously that oxygen needs to come in sterilely, which can be somewhat tricky, especially as you scale into these larger systems, but it's definitely possible, and that's how a lot of these big farms in China are operating. And then after that, you got monitors, that sensors that can be hooked up to these things if you're really fancy. A lot of what I use, you see on this bottom photo here, is just mason jars. I don't have any sensors. I just have a standard SOP that I kind of follow with a majority of my species. But depending on what you're doing, you can fine tune each recipe to the species you're working with. And if you're really fancy and are lucky enough to have some of these sensors, you can really fine tune it even further and use things like a chemostat or a turbidostat, and then that would really amplify and stretch the peak period of how long and aggressive your mycelia will be in turn for using it for colonizing your either substrates or your spawn. So then after that, mainly the bioreactors allow us to grow just a large amount very quickly in comparison to using something like just a petri dish. So it's easily reproducible, uh, especially if you want to make those functional compounds or those enzymes in a controlled and repeatable way. It's a lot easier to do that with this method. Um, it's essential for industrial scientific applications, and it's used quite broadly across all uh, cell culture. So if you want to do this or get started with it, some of the materials that I would say are required would be that you're going to need an autoclave or a pressurized vessel that can sanitize and sterilize your material. This is the one that I have at my home, and it's basically it's called a SH Scientific 150 liter is what this one specifically is. But if you don't have the funds to do something like that, you could use something as simple as just an Instant Pot or a Presto pressure canner. But this is all it's going to do is raise the pressure up to about 15 psi roughly, and you will sterilize that whatever you're using, whether that be your substrate blocks, your liquid culture, your agar. You'll put that in there for a few different time periods depending on what you're actually putting inside, but then that will kill all the microbes that are living inside. So then you can work with a clean, sterile medium and then inoculate only one fungus at a time. So next would be that you have a fermentation vessel, and this fermentation vessel that I've created and designed is one of the cheapest options that you could use. You could maybe even make it a little bit cheaper, but this is the most functional and cheapest option that I could possibly build. You could build this, for less than a few dollars if you were to find and source all the materials online. I find it to be the most useful, and then you could easily scale this system up to be a little bit larger. But once you get above, say, about 5,000 milliliters, it starts to get a little clumsy, and then you would need to really start getting into some fancier stainless steel equipment. And then after that, you're going to need your nutrients. I just put this malt extract here just because that's the main sugar that I like to use, but really you could use any sugar source if you wanted, but just understanding the differences between your simple sugar and your complex sugar is really important, and how and what your end goal is to, what your recipe will be, I guess, inside this fermentation vessel. And after that, you're really going to need a HEPA filter. That's one of the main backbones of all mushroom cultivation, is using and working in front of what this is just basically a fan that blows clean air. So once you go through this whole step and process of sanitizing you're sanitizing or sterilizing your media, you can then have it open and work in front of this clean flow hood or HEPA filter, and this will ideally keep any contaminants from getting inside your workspace or contaminate what you're currently working on. This is, small. You see these small mycelial pellets. All that is the mycelium inside the reactor, and that's growing over time. This is a pretty thick mycelium that's growing in there. But the benefits here of using these is that you're going to have really fast colonization. It's super consistent. It's really, really easy to scale. You could have hundreds of these liquid culture jars, and it's not going to take up a lot less space than, say, if you were to use tons of spawn or some of these other methods. It's very versatile. You can do this with any mushroom species, and honestly, some of these harder to grow ones definitely really require this sort of thing, or you're going to be waiting, sometimes up to a half a year or so to produce some mycelia that's as thick as this jar is. And pretty much any large or small scale farm uses this sort of application in one way or another. And it's very cheap and accessible. So really, anybody can do this. You don't need $1 million to start, getting started with this sort of thing. And then, like I said, it's super easy to store. I've created some different methods on how to dispense it even easier, but really all you need is to attach a syringe to the top of this vessel. It has a lure lock system, which I'll get into in the next clip here. And yeah, so here's the style of this reactor. On the left side, you see the top, which you'll have one syringe port here, and that syringe port is just only there so you can do a quality control, or you say ordered some genetics or liquid culture online, and if you want to immediately, without actually opening up the jar, you could inoculate through this syringe port and not worry about introducing any sorts of contaminants. It's also, like I said, a really easy way to do quality checks. Say if you wanted to see if your liquid here is still clean, you could then in turn, pull a syringe out and then add some of that to a Petri plate and then look at, how clean or alive and aggressive your mycelium still is. And then on the left is an exhaust port, which I said is pretty important for growing mycelia, since air is a big restricting factor. If there's not enough air, the mycelium is going to grow extremely slow. So this is just, in a sense, as an exhaust port. I make other systems that, if you look on the right side here, these are actually to attach to this other port, and that would be an air intake. So you don't need or required to add air. You could just use a stir bar if you really wanted to keep it simple. But when you add air inside the mycelium, that's how you'll form stuff like those pellets that you saw previously, or those like little mycelium pearls. But yeah, this is just a little attachment basically that will connect up to this here, which is just a cap to lure lock system. So these lure locks, pretty much just twist together. And then this system here actually has some silicone grommets that are holding the silicone in place. But if you look at this lower photo in the middle, that's a thing called a bulkhead through port, and basically it just has a little silicone grommet on there as well, and then a little plastic nut that screws on in between to hold them tight. So you could use a few different options here, whether it's the silicone grommets or these through bulkheads, and either way it's going to do the same application in the end. But these three components I find to be pretty necessary at the minimum to utilize liquid culture at any scale. But like I said, you have your air here, and if you see, and you kind of got to look a little close, but there's a big disc on it, which is basically a big filter. So the air gets pushed through that filter and then is inputted in a clean way. It goes through a 0.2 micron filter, and anything that's, you don't really have to worry too much, because mostly everything or the contaminants can't fit through a 0.2 micron filter. So this is how adding air stays clean in a sense. And then if you see this top photo here, this is actually something known as just a check valve. You could also use a pinch clip. These check valves work easy. Pinch clips are super simple as well. They kind of perform the same function, but since there is kind of a long air tube right here, what tends to happen if you have a really small syringe, like let's say a 10 millimeter versus a 60 millimeter syringe, or milliliter, sorry, you would basically attach this, and if you didn't have the check valve or pinch clip, it would suck in a bunch of air, because basically in between here, like a straw, you have a bunch of air space. So that just in turn removes that air space, and then yeah, you can pull up as much liquid culture as you want and then dispense it however you want to go about dispensing it. Sometimes people will even set up things like peristaltic pumps, which is something that I've found at larger scales to be really useful. Otherwise, you're going to find yourself getting carpal tunnel as you're pulling thousands and thousands of syringes. here's just a basic liquid culture recipe that I find for, those half-gallon jars, or 15. They're 2,000 milliliter jars, but really I only fit about 1,500 mils to 1,250 mils in each jar. I like to have a little bit of headspace. That headspace really allows air to circulate inside, and not let too much get. Uh, Sometimes you'll create some foam in there as it's aerating or even spinning. So if any of those filters get wet on the way out, they're actually hydrophobic filters, which is like I said, if it gets wet, it just clogs and then will no longer let air through. And then you basically end up choking out your mycelium when those filters clog. So you want to avoid that. That's why I let a little bit of headspace in the top. But here is a liquid culture recipe that I'd recommend. I'm not going to go into all the different ingredients here. You can see it on the screen. But yeah, you can switch these around a little bit here and there depending on your exact application and what you're trying to achieve. This is mainly just for a basic cultivation recipe. This is a little bit maybe further than some people might go, but it just, again, depends on what you're trying to do and how fast you're going to use this liquid. So the liquid culture process, it all starts with basically you're going to have your nutrients and you're going to add those nutrients into a vessel. I have a video on this that will be just after this slide. But basically you have your nutrients, you're going to add that nutrients all into your jar. And a really important step I find is to either add hot or slightly boiling water. I'd say, just hot water is enough, but you want to dissolve those nutrients into the solution so they become more available to the mushrooms. Some people like to add a little bit of uh, some sort of carbon in there that can actually give the mycelium to grip onto, and that helps too. But the only issue there is that you in turn might end up clogging up your silicone tube as you're trying to extract the mycelium out from that. But I try to use the biggest tubes on my setup here, but you really could get away with adding a little bit, assuming that you're not letting it colonize too far, because they will get so thick that it just will not suck out the tube anymore eventually, and then you'll just have to unscrew the cap and pour it out by hand, which kind of defeats the purpose of the whole reactor or fermentation vessel that I created there. And then with that recipe I mentioned, you usually, if you followed what I said, you'd be within about the pH of 5.5 to 6.5. But let's say you did something a little different. You would want to adjust that with some lye or citric acid so you could, get back into the range where fungi thrive, which is a little bit more of an acidic side. Bacteria tend to thrive on neutral to more basic type of uh, pH, whereas fungi tend to thrive in more of a neutral to acidic pH. And then you'll sterilize your reactor. You pressure cook the vessel for a minimum of 25 minutes at about 15 psi. Depending on the size of your reactor, how much you're doing, you might need to vary this slightly here and there, but this is about the standard, what people do, at most scales. And then after that, once you open up your pressure vessel, you'll then want to, I guess before you even cook it, you'll want to make sure that you leave some airspace in there so that you're not actually creating a vacuum when this happens, or not allowing the pressure to get inside and sterilize the media that is inside the liquid or inside the jar. Because if you create pressure inside the jar, you either might have a jar break, or if you release the pressure on your vessel too quickly, a lot of these jars aren't, at least the mason jars or ball jars, are not really made for that sort of pressure to, or escape to pressure, or you know what I mean. But there are ways to go further with that. You could, get a stainless steel fermentation vessel. You could get a borosilicate. These are significantly more expensive, which is why I came up with this design in the first place, is because I want to minimize and maximize my output as much as possible. And I find that these reactors really do that trick. Then, like I said, once you open that pressurized vessel, you're going to basically seal up that jar again and then set it in front of a HEPA filter so it can cool down in a sterile environment, and then not worry about introducing contaminants in the time period of when you're waiting for your liquid to cool down. So then in turn, you could inoculate it with your genetics. So yeah, that's the process of how to make liquid culture. And now here's a little video on it as well. All right, so now we're going to talk a little bit about the inoculation aspect of it and the different types of materials you could use to do this sort of thing. Number one, your gold standard is going to be to take a pre-made sterile liquid culture syringe, or even a whole jar, and inject the material that you have into it. Like I said, through that syringe port, or you could just go and use the lure lock as well. But going from a liquid to a liquid is going to be the quickest option. It skips any sort of recovery phase that usually happens with a petri dish inoculation. So the petri dish inoculation, usually people are just taking a few cuts out of cutting it up like a pie in a sense, or a pizza, and then they'll use those pieces and open up their jar and then put them inside the jar in front of a HEPA filter. And that works equally as well. But there is usually a little bit of a recovery phase in it. So sometimes when people do that sort of application, they'll let it rest for a few days before they actually start to mix and aerate it. I like to usually use very small agar wedges in the process of this because, like I said, if you have too large of pieces, they're going to get stuck in that tubing when you go to extract the mycelium. So you really want to keep these wedges as small as possible, just so you don't run into that issue. And then the last thing you could do, which I highly, highly say don't even bother with, but some people will try it just because this is what's available to a lot of people and they find it, or they bought one once upon a time and they really want to use it. So, which is using spores and putting spores into a bioreactor. So if you can somehow find, in a sense, sterile and clean spores, which is incredibly difficult. You're not going to be able to do that from a wild clone or wild tissue culture or tissue or anything like that. So you will have to grow something sterilely inside of a bag to achieve this sort of thing. But let's say you bought one online, chances are it's most likely going to be contaminated with either a bacteria, yeast, or whatever. And then if you put that straight into a highly nutritious liquid, like the recipe I showed you earlier, it's just all these bacteria and yeast are gonna outcompete your fungus, and you're not gonna grow anything you want. You're just gonna grow a bunch of bacteria and yeast and wonder what happened. So usually what happens when you get a spore plate, or say you got some sort of spores you want to work, you would work this way from right to left. So you would go with your spores, you would then put them onto a petri plate, because on a petri plate it's 2D, and then let's say the spores germinate on this petri plate. You can see the direction of where the clean mycelium is going, and then not take any of the infected material or infected parts of the petri plate in turn. So that's kind of why I don't suggest using spores into a liquid culture, or even using spore syringes if you got one. I would say take that spore syringe, or spore swab, or if you just have a spore petri plate that someone gave you, or whatever it is, a tinfoil piece, take a swab of it and germinate your spores onto this media, this petri plate media, so you can in turn isolate the mycelium as much as you can. You might have to do a few transfers before it actually becomes completely clean. So, but then in turn, once you have a clean mycelium growing like the one you see in the middle, which is a chicken of the woods culture, then once it's clean, you can go ahead and add it to nutrient media, which then you're not going to be worried about any contaminants growing or other microbes that uh, are unintentional. So how does the aeration part work? We'll go a little bit more into that here. So aerating a liquid culture entails just using a sterile filtration system. Like I mentioned earlier, you have a zero point 0.2 micron sized filter membrane, and this is going to act as your air intake. And then you'll actually have another one on your exhaust. So you have 2.2 micron filters that basically aren't allowing any sorts of other microbes inside your fermentation vessel. So let's say once you actually create and uh, produce your finished liquid culture, you don't need to store it in front of a HEPA filter for eternity. You can go and then store it in the fridge once it's fully colonized, so you can get to it when you need it, or just store it on a shelf somewhere. You don't need, that's why I'm saying it's so much easier to use these sorts of things and store them, because you don't need all these bells and whistles to keep things clean and in a perfect environment. You can just, you know, spray some isopropyl on the outside of the fermentation vessel before you work with it again. And then in turn, that should clean it up enough for you to be able to use it again whenever you want to get to it. I usually store mine inside a fridge when I'm not utilizing them, when they're fully colonized. But then, yeah, you can then go ahead and use it whenever you want. That's the benefit of it, is it stays good for quite a while. Actually, you can have some liquid cultures, stay good for anywhere from 6 months to a year. I don't say I'd recommend keeping them and storing them for that long, because something can go wrong. They're just a small little filter. Something can get through that filter pretty easily in that time period. But yeah, that's kind of the benefit, is like when we add air, we're adding more dissolved oxygen into the liquid to help the mycelium grow faster, because mycelium and all fungus, or most fungus, are not anaerobic organisms. They're aerobic organisms, so they require this oxygen to go through their metabolism and break down this material and grow and grow and grow to see what you saw earlier, those big mycelium pearls. uh, and then, yeah, how long does it take? Usually only takes about 8 days if you're on a constant supply of air for most species. Um, that can vary here and there depending on your recipe that you use. You can also, and the type of inoculation you use, like we went over a minute ago with the liquid to liquid versus the Petri plate approach. I personally usually use a master culture jar. Like I'll keep one jar of uh, a jar that I inoculated with a Petri plate that's growing a bit slower, and then I'll use that to inoculate other production jars later on, and then utilize those production jars instead of always making more and more uh, Petri plate to. It's just way easier to do it this way. You can basically have one jar that you're pulling from to inoculate your other bigger jars. But yeah, like I said, on those 8 days, you're going to have a constant supply of air during this time period. At the end of that 8 days, you can then take it off the air. If you're using and inoculating with a Petri plate, I personally would recommend that you would start with put it on a spinner plate for at least 5 minutes, maybe even 10 minutes a day on those first 3 days, just in case, say, you used too big of agar wedges or something like that, because you really want to mechanically break those. You want to be gentle in this whole process. Don't be too aggressive, but ideally you want to break up those big colonies into smaller colonies so you can have a lot more surface area for your inoculation. So some of the Myco-Op offerings that I actually, you know, offer to the public are sterilized substrates, grain spawn, wood-based substrates, coconut-based substrates, that sort of thing. I also offer a lot of genetics. I have a pretty large library of uncommonly cultivated mushrooms from the United States that are, mainly highlighting the native species. I sell the colonized petri plates and aerated liquid culture syringes that you can jump right into your cultivation journey with that. And I find it to be a lot more useful to rely on someone that knows, that side of it, because if you mess one of these parts up in the beginning, it's just gonna get worse. You have to be perfect. There's no like, it's all or nothing throughout this whole process. Either you did it right and you were successful. There's no in between. It's either you failed or you succeeded. The other offerings I have are consultations. You can take a look at our website or message me directly. I'll have my contact page listed just right after this. But if you want to learn a little bit more how to scale your mushroom farm or learn specific techniques that I showcase on my Instagram or TikTok, like force hydration, or if you want to learn more about this aeration and how to utilize it more specifically, feel free to reach out to me. I'm happy to help as much as I can. I also offer some ready to fruit kits. You can contact me again through the email or social media, like I said, and you can see what's currently available. I offer a pretty large variety of grow kits. I keep a lot of different cultures in stock, but it changes throughout the season just because certain species tend to thrive in certain seasons. But yeah, please reach out if you have any other questions about any of that. And yeah, so if you want to contact me here, Courtney Osborne at myco-op.online is my email. Follow me on Instagram, myco_op. Uh, my Facebook is also just Myco-Op. I also have a TikTok that's Myco-Operative. My web store here is myco-op.online. And yeah, thanks for listening. I hope that you guys learned something. Again, if you have any questions, please reach out, and I'm happy to help as much as I can. Thanks for watching.